Hello there, thank you for clicking on our poster. In this work, we evaluate the performance of complementary rebinning reconstruction algorithm within the scope of application in an off-center panel detector in CBCT imaging. As an introduction, a half-band operating mode is usually adopted in 3D CBCT imaging. This is achieved by laterally displacing the 2D flat panel detector by a certain length, as shown in the figures in the slide. The objective of displacing the detector is to achieve a larger field of view region as highlighted by the red circle. With the larger field of view, tumors near the thoracic regions can be located. However, the half-fan operating mode requires a full scan where the source detector module is rotated for 360 degrees. This eventually causes ring truncation artifacts to occur within the reconstructed images, thus degrading the image altogether. This is actually due to the asymmetrical cone geometry represented by a length of 2 delta as shown by the yellow region in the figure. Various methods have been developed to mitigate the ring artifacts that are due to the truncated projections. Intuitively, one could adopt the standard iterative-based methods that would indirectly improve the image overall, though in the expense that it is more time-consuming. Analytical-based methods, on the other hand, have also been developed. This includes the projection weighting method. However, studies have found that the projection weighting method causes unwanted shading artifacts as repercussions. Therefore, we evaluate a repurposed complementary rebinning approach to mitigate the truncation artifact while preserving the overall intensity of the reconstructed images, thus avoiding the unwanted shading artifacts. In this work, two truncation artifact mitigation algorithms are compared and evaluated. A similarity between the algorithms is that both are performed in the projection space. The projection weighting algorithm basically applies a smoothing function, as shown in the slide, on the 2D projection along the lateral direction where it is truncated by the asymmetrical detector. As for the complementary rebinning algorithm, firstly, the 2D projection images are rebinned from the default fan beam geometry to the parallel geometry. Subsequently, the parallel rebin projections are rebinned complementarily based on the conjugate angles, such as the figures shown in the previous slide, thus completing the projections that were truncated earlier. Then, the rebin projections are reconstructed using a half-scan angle as opposed to the original 360-degree ring. To evaluate both algorithms, three assessment metrics are utilized in this work. That mainly involves the quantitative evaluation between the reconstructed images from both algorithms with respect to the available ground truth for all 5 digital phantoms. First is the RMSE that assesses the overall quality of the reconstructed images. Second is the scaling factor to evaluate the occurrence of any intensity bias overall using the more penrose pseudo-inverse matrix of the reconstructed image. And the third metric is the tissue interface sharpness to assess the regions in the images that are vulnerable to blur artifacts due to respiratory motion. Overall, the complementary rebinning algorithm averagely yields a significantly better reconstructed image compared to the projection weighting algorithm based on the root mean squared error metric. Using the scaling factor, it is found that the projection weighted images yielded an average factor of 2.03, which indicates an intensity bias of almost 50% decrease in intensity compared to the ground truth. Based on the scaling factor of the complementary rebin images, the average 1.01 value indicates that almost no bias, which means that the intensity of the reconstructed images using the complementary rebinning images is preserved. Additionally, based on the third metric that assesses the motion blur artifacts, it can be found that there are no significant differences within the quantification of motion artifact between both algorithms with a probability of 0.23 at a 5% significance. Therefore, based on the results shown as a conclusion, comparing between the two analytical-based ring truncation artifact mitigation algorithms, the proposed complementary rebinning algorithm is able to produce a reconstructed image with a similar sharpness quality as reconstructed by the standard projection weighting algorithm while preserving its overall intensity, thus avoiding the unwanted intensity bias shading artifact.